Hello friends, today we shall discuss about the easiest and the quickest way to solve quadratic equations. Now before going into the details, let's learn what is a quadratic equation. Any equation of the format ax squared plus bx plus c equal to 0 where a, b and c are real numbers and a is not equal to 0 is called a quadratic equation. Now, generally, we know two different approaches of solving any given quadratic equation. The first one is the Sridhar-Acharya formula, and the second one is the middle term factorization. What we shall learn today is the third method, the easiest and the quickest one to solve any given quadratic equation. Let's start with an example. Say we have a quadratic equation like x square minus 6x plus 8 equal to 0. We know that the middle term, that is the coefficient of x, will give us the sum of the roots, and 8, the constant term, will give us the product of the roots. So what we do is we divide the middle term 6 into two parts, 3 plus u and 3 minus u, and multiply them to 8, the constant term. Expanding which we get 9 minus u square equal to 8, u square equal to 1, u equal to plus minus 1. Hence the two roots are 3 minus u, 3 minus 1 equal to 2 and 3 plus 1 equal to 4. Confused? Let me explain. This is the quadratic equation we took. Now, before going with this approach, we have to make sure that x square has a coefficient of 1. The x term is preceded by a minus sign and the constant term is preceded by a plus sign. Now, whatever is the middle term, we divide it into two parts, 6 by 2 minus u, 6 by 2 plus u. If we multiply them, we should get 8. And we know the formula from basic algebra that p minus q into p plus q equal to p square minus q square. We apply it here to get 9 minus u square equal to 8, u square equal to 1, and u is equal to plus minus 1. Hence, the two roots, one of them is the blue box, one of them is the green box. They turn out to be 3 minus 1 and 3 plus 1. Let's take one more example and check. Say we have x square minus 8x plus 15 equal to 0. First criterion, x square should have a coefficient of 1. The x term is preceded by a minus. The constant term is preceded by a plus sign. Okay, so 8 has to be divided into two parts, 8 by 2 minus u and 8 by 2 plus u. Multiplying them, we should get 15. Expanding it, we get 16 minus u square is 15. So u square is 1, u is plus minus 1. So the roots are 4 minus 1 and 4 plus 1. Now you must be wondering, what if the middle term doesn't turn out to be an even number? What if it's an odd number which is not divisible by 2? Let's take an example like this, where the middle term 7 is an odd number. We divide it into two parts, 7 by 2 minus u and 7 by 2 plus u. Multiplying them, we should get 12. Expanding, we should get u square equal to 1 by 4. U is equal to plus minus half. Hence the roots are 7 by 2 minus half, 7 by 2 plus half. What if the signs are different? Say we have an equation where now the x term is preceded by a plus sign and the constant term is preceded by a minus sign. What we do is we convert the entire equation into the format that we want. So now in this new format, the x term is preceded by minus and the constant term is preceded by plus. Now the middle term is minus 1. We say minus 1 by 2 minus u, that's the first part, minus 1 by 2 plus u, that's the second part. Multiplying them, we should get minus 30. Expanding, we get u square equal to 121 by 4, so u is plus minus 11 by 2. Hence the roots are minus half minus 11 by 2, minus half plus 11 by 2. What if, let's say, x squared doesn't have a coefficient of 1? If we have an equation like this, we divide the entire equation by 2 and again we bring it into the format that we actually want. Now divide minus 5 by 2 into two halves, minus 5 by 4 minus u and minus 5 by 4 plus u. Multiplying them, we should get minus 6. Expanding, we get u square is 121 by 6. So u is plus minus 11 by 4. Hence the roots are minus 5 by 4 minus 11 by 4, minus 5 by 4 plus 11 by 4. What if we have a quadratic equation which is not exactly solvable using the middle term factorization? So basically, it will take a lot of time if you try solving it using the two general methods that we know. If we apply the third method here, let's see how easy it becomes. Again, as we can see, x square is preceded by a 2. So we divide the entire equation by 2 and bring it to the format that we want. Now minus 3 by 2 has to be divided into two parts. Minus 3 by 4 minus u minus 3 by 4 plus u. Multiplying them, we should get minus 11 by 2. Expanding, we get u square equal to 97 by 6. As we can see, 97 is not a perfect square. So u turns out to be plus minus root 97 by 4. Hence the roots are minus 3 by 4 minus root 97 by 4 minus 3 by 4 plus root 97 by 4. So you can see how a very complex equation in a quadratic equation can be solved this easily in this much lesser time. Can we extend the entire solving method to quadratic equations which have imaginary roots? Yes, we can. If we have a quadratic equation like this, now we can see that x square has a coefficient of 3. So we divide the entire equation by 3 and get it into the format that we want. Now we divide minus 1 by 3 into two halves, minus 1 by 6 minus u, minus 1 by 6 plus u. Multiplying them, we should get 2. Expanding, we get u square equal to minus 71 by 36, which shows us that the roots of this equation will be imaginary. Hence, u comes out to be plus minus iota root 71 by 6. Hence, the roots are minus 1 by 6 minus iota root 71 by 6 minus 1 by 6 plus iota root 71 by 6. Hope it helped.